A casual spectator at a sporting event is assuredly acquainted with a phenomenon where some player on the field goes on a torrid streak where he can apparently do no wrong. In basketball parlance, this is sometimes called a hot hand. To put things in context, consider the following setting. Exhibit A, a basketball player, a good player. He typically makes one basket out of every 2 shots he takes. Imagine that in a game where he takes many shots, say 50 shots, somewhere in that sequence, he scores 5 baskets in a row. We say that he has a hot hand. Conventional wisdom dictates that scoring 5 in a row for a player who typically makes 1 and 2 is unusual, right? The chance that if he just takes 5 shots, say the first 5 shots, the chance they all go in is only 1 in 32. This looks very small. And therefore, the fact that he has made 5 in a row seems to be bona fide evidence that he is on a purple patch. He has a hot hand. He has an altered mental state where he can do no wrong, and therefore it is natural for fans and for his teammates to try to milk that run of successes as much as possible by getting him the ball so that the entire run can be milked. Now, this is so self-evident, and we all buy into it, that it hardly needs defense, or does it? Here is a counterintuitive possibility. What if, on the other hand, this streak of successes for this player is not at all unusual, but is just to be expected from sheer chance fluctuations? We now have another possibility, almost heretical, because it seems to run so counter to our native intuition. But having put it up there, we now have 2 possibilities. Which of these is actually correct? Of course, our coin-tossing example and our examining of streaks of successes, success runs, points the connection to the coin-tossing problem. And this enables us to put in place a principled statistical test of a hypothesis. What does the test comprise? Very, very simple. Imagine that a player has taken 50 shots and he's got a particular sequence of successes and failures in making baskets. The test involves comparing the statistical properties of that sequence with what one would get if one tossed a coin 50 times. This is an example of what is called in German a Gedanken experiment, a thought experiment. I don't actually have to toss a coin 50 times, but I could certainly conceive of it. Imagine that one were to toss a coin 50 times. Would the sequences of heads and tails, successes and failures that we obtain, look statistically different from what we observed for the player on the court? And now, of course, the surprising results that I had put before you suggest that there is a test we can make by comparison, and that the test might have an unexpected result. Now, this is a political age, and a political age demands a slogan. So let me promptly give you a slogan. And here it is. The more likely it is that in a string of coin tosses, we observe a success run of the length that we see on the court, the less there is evidence for a mysterious, otherworldly hot hand. Let me rephrase this. After all, if in a string of coin tosses, it is not at all unlikely that we observe 5 heads in a row somewhere, then why should we, because we observe 5 successes on a row on the basketball court, ascribe to it anything unusual, otherworldly, magical. No, such phenomena are readily explicable by just natural, random, coin-tossing fluctuation. And indeed, the table I've given you gives us immediate evidence, in this time against our basic hypotheses. Imagine that the coin was tossed 50 times. We are looking for a success run of length 5. The odds of this, as we see in the table, are 55%. If one tossed a coin 50 times, then 55% of the time we'll observe success runs of length 5 or more somewhere. It is not at all surprising, therefore, that a player who makes 1 and 2 baskets will, in a string of 50 attempts, somewhere make a string of 5 in a row. Now, this suggests that there is no evidence for the hot hand for the particular example I had contrived. But this was a starting point for an extensive and deep statistical investigation by a team of 3 statisticians, Gilovich at Harvard University and Vallone and Tversky at Stanford University, and they published the results of their study in 1985. They had examined an entire season's worth of players' efforts in the National Basketball Association, and this was the conclusion. Based on careful statistical analysis of all that data, they concluded that the hot hand theory is a widespread cognitive illusion affecting all beholders, players, and coaches alike. In other words, there was no statistical evidence at all in favor of a mysterious hot hand. Everything that was observed could be explicable just by natural, random fluctuations. A postscript to the story. It's amusing in its own right, but a postscript here. This is reported by Daniel Kahneman in his wonderful book of 2011, Thinking Fast and Slow. And Kahneman reports that, perhaps apocryphally, a reporter for the Boston Globe took the results of this paper and went to the redoubtable coach of the Boston Celtics, Red Auerbach, and said, "Hey, Red, this guy at Harvard says that there's nothing at all in this idea of a hot hand. It's all explicable by chance." To which the famously erasable Red Auerbach apparently grunted, "So, some guy did a study. What do I care?" But of course we do care. As the probabilist William Feller has remarked, even strong faith must be subject to a statistical test. And our question then is, how do we put such principled tests together so that we can come up with logical conclusions? This, in essence, is the heart of our course.